Struggling to get your self-balancing robot up and running? In this video, we'll dive into all the troubleshooting steps you need to make your robot balance perfectly. From sensor placement to wheel size, wiring, coding, and Bluetooth connections, we'll tackle every challenge step by step. Plus, I'll share some pro tips to solve common issues as well. Stick around till the end for an epic robot demo you won't want to miss. Let's get started. Here is the list of the topics covered in this video. It's ideal to place the sensor in the middle. Here, I positioned it at around 110 millimeters. But remember, this isn't a strict rule of thumb. Using larger wheels is better for stability. I'm using 100 millimeters wheels for this setup. To understand the MPU6050's axis, look for the small axis markings on the board or refer to the datasheet. These define how the sensor detects movement in 3D space. To get started, first head to the GitHub repository of BalancingWii. Click the green code button and select Download Zip to save the files to your computer. Once downloaded, extract the zip file and open the project folder. Launch the Arduino IDE, then go to File, Open, and select the sketch file from the extracted folder. Before uploading the sketch, it's important to configure the settings. Open the config.h file within the project and locate the section for axis selection. Here, choose the correct axis that matches the physical placement of your MPU6050 sensor. This step ensures the robot interprets the sensor data accurately. Once done, you're ready to upload the sketch. Ensuring all connections match the instructions on the GitHub page is crucial for the robot to function properly. Even a single wrong connection can lead to errors or damage to components. If your robot keeps moving in one direction, double-check the wiring between the motors and the driver. It's likely a connection issue. Simply follow my connection. To connect to the Bluetooth module, open the EZ-GUI app and enable Bluetooth on your phone. Select your module name and click Next. Select Multi firmware and click Next. Disable text-to-speech and click Next. Have you noticed the refresh rate? I see a lot of packet losses as this app is no longer maintained. We will see workaround to increase refresh rate in the next section. Just click Next for now. Now click on the Connect button. Once connected, you will see received and sent packets on the upper section. Now put your robot on the flat level surface and calibrate accelerometer as shown here. If your robot refuses to arm, go to Settings. Enter 500 refresh rate. If you want self-centering joystick feature, tick the Back to Mid options and then go back and disconnect and connect again. I spent 2 days finding the root cause of this issue. Now go back to Control menu and arm your robot and it will come to life, and you will also get self-centering joystick feature unlocked. Now that everything is set up, it's time to see the self-balancing robot in action. Watch as the robot balances itself effortlessly, reacting to every tilt and movement with precision. It can glide forward, roll backward, and even perform tight turns, all thanks to the MPU6050 sensor and finely tuned code. Notice how stable it stays even when nudged or moved on uneven surfaces. This level of performance comes from proper sensor placement, accurate wiring, and calibration. With a Bluetooth connection, you can control it wirelessly, making it fun and interactive. This is just a glimpse of what your robot can do when it's set up correctly. Stick around for more tips and tricks, and start building your own masterpiece today. I am DHK Dude, signing off.